Hello everyone, and let's continue from where we stopped last time. In this video we'll talk about lab 3 and 4, SQL injection union attacks. So let's continue. So SQL injection union attacks, when an application is vulnerable to SQL injection and the result of the query are returned within the application's responses, you can use the union keyword to retrieve data from other tables within the database. This is commonly known as SQL injection union attack. The union keyword enables you to execute one or more additional select queries and append the result to the original query. For example, we are selecting column A and B from table 1 and we want to select more data from other tables, so what we'll do is union select and then column CD from table 2. This SQL returns a single result set with two columns containing values from column A, B from table 1 and column C, D from table 2. So basically, instead of returning two columns containing the result of column A and B from the first table, we are adding the column C and D into that mix. So now we'll have a result containing two tables. So let's continue. For a union query to work, you have two key requirements that must be met. The first requirement is that the individual queries must return the same number of columns, and the second one is that the data type in each column must be compatible between the individual queries. So what does that mean is that on the first condition, if you have on table A, let's say 3 columns, and that's what the application is using on this current page, you can just say I want to union select 2 columns with that from a different table. That will not work. The number of columns from each table must be the same. If the application is using 2 columns from a table, you must use 2 columns as well. And for the second condition, if the first column from the first table, I know that's a little bit confusing, but let's continue. If you have table 1, and let's call it table cars, and then the first column is the color, and let's say it's red on the first table, so you have a color red and that's a string, and then you want to concatenate as next table with it, let's say the table of cost, let's say for the car, the reinsurance cost, and then for the second table, the first column is numbers, the insurance numbers. So you can't concatenate the first 2 columns or the first column from each table, because on the cars table you have the color and on the other table you have cost, so these two will not match together. To carry out a SQL injection union attack, make sure that your attack meets 2 requirements. This normally involves finding out how many columns are being returned from the original query, which columns returned from the original query are suitable data type to hold the result for the injected query. So here you will try to fuzz the application or try different payloads each time, and depending on the logic of the application, how it responds to you, you should know these 2 information, and from there you can craft your attack. And now let's move to determining the number of columns requirement. When you perform an SQL injection union attack, there are 2 effective methods to determine how many columns are being returned from the original query. One method, which we didn't talk about yet, is called order by. So order by clauses are incrementing the specific columns index until an error occurs. For example, if the injected point is a quoted string with the where clause of the original query, you would submit. So here's our example, and we're entering single quote, space, and then order by 1. So what will happen is that you're telling the application, hey, let's say you have 3 columns and then I want to order by the first column. So now the order of the page will change. So you will see changes when it comes to how the page looks, and same when you do order by 2, you're ordering by the second column, and so on and so forth, until you hit a number where the application doesn't have that column. Let's say the application has only 4 columns and you're saying order it by the 5th one, and if the 5th one it doesn't exist, it will either give you an error, tells you that hey, this does not exist, or it might just do nothing and you will see no changes to the page. Then you know that this column does not exist, or any other kind of anomalies that will happen. So this series of payloads modify the original query to order the result by different column in the result set. The column is an order by clause and can be specified by an index, so you give it a number. So you don't need to know the names of any columns, and this is good because when you try to, let's say, do an SQL attack, you don't usually know the name of the columns that they have, or even the name of the tables, or even what's the database they're using. So basically you try to figure out things step by step, and you don't just directly jump to attack. When the specified column index exceeds the number of an actual columns in the result set, the database will return an error, such as the order by position number 3, which is in this example here, is out of range of the number of items in the select list, and this number is subject to what the user inputs. It can be 3, it can be 10, 50, it depends on how many columns does the database has. Additionally, the application might actually return the database error in its HTTP response. So when you submit this order by and you get your HTTP response, the application might just give you a database error, and that will be more helpful when it comes to knowing the database version and what's the database type and everything. But it may also issue a generic error response. In other cases, it may simply return no result at all. So if you give, let's say, order by 10 and you see no difference, it means that this column does not exist. Either way, as long as you can detect some differences in the response, you can interfere how many columns are being returned from the query. So let's continue. Our second way of knowing it is using the union clause, as we talked about before. The second method involves submitting a series of union select payloads specify different number of null values. So it differs than the order by, because order by you give it a number and like orders by the first column, but in the union select you're combining two tables together or information from two tables, and in this case you don't have any other table to use. So basically you'll give it a null and say that, hey, I want to combine table 1 with values that's null, basically no values at all, and this will determine the number of columns that you have. You can enter one null and it will mean one column. If the application returns an error, you make it 2, 3 and so on until you reach the number where it matches exactly the number of the table 1, and then it will return the correct answer. If the number of null does not match the number of columns, the database returns an error such as all queries combined using a union, intersect or except operator must have an equal number of expressions in their target lists. So basically, even if you have, like, let's say you're selecting 3 nulls and the database table has only 2, you still get an error. If you select 1 and it has 2, you still get an error unless you select the exact correct number. We use null as the values returned for the injected select query because the data types in each column must be compatible between the original and the injected queries. Null is convertible to every common data type, so it maximizes the chance that the payload will succeed when the column counts is correct. So basically the second condition was for the first table and second table to have the exact same data type, and because you don't know, let's say it has 2 columns, you don't know the data type of the first column, neither for the second. So what you do is you put a null and that's compatible with every data type, whether it's integer, string, etc. And so the null will make it work if it has the exact number of columns, and then you can try to see what is the value of the first column. Is it a string, is it an integer, or is it any other data type? As with the order by technique, the application might actually return the database error in its HTTP response, but may return a generic error or simply return no error. When the number of null matches the number of columns, the database returns an additional row in the result set containing null values in each column. The effect of the HTTP response depending on the application's code, so 200, 302, all of these status code that we talked before. If you are lucky, you will see some additional content within the response, so you'll have additional empty row, so now you'll know that this is the exact number, such as an extra row in HTML table. Otherwise, the null values might trigger a different error, such as null pointer exception. In the worst case, the response might look the same as the response caused by an incorrect number of nulls, and this will make this method ineffective. So it really depends on how the application behaves when it comes to testing it. Continue. And now we have our first lab. So SQL injection union attack, determining the number of columns returned by the query. Let's read the description. This lab contains an SQL injection vulnerability in the product category filter. The results from the query are returned in the application's response, so you can use the union attack to retrieve data from other tables. The first step of such an attack is to determine the number of columns, as we said before, that are being returned by the query. Then you will use this technique in subsequent labs to construct the full attack. So basically in this lab we only need to determine the number of columns, and in further attacks or further labs we will use the same attack to retrieve the whole database information. To solve the lab, determine the number of columns returned by the query by performing an SQL injection using the union attack. So let's start the lab. Alright, and the lab rendered. So now we have a table of 3 columns as what we can see, but bear in mind that there might be some hidden columns that we can't see. And as for now, let's click on any category, let's say gifts, as we did before. So this is the data returned by the gifts, and as usual we can test it by using single quote and see what's the error, and we get an internal server error as usual, so we can remove it. And by the way, this is just the URL encoded format of single quote. We can use the group by. So let's just try it, group by 1, and I don't really remember what was the original data, so let's group it by 2 and see the difference. But for now we have these are the order. We got an internal server error. This is weird. Let's see, by 3. We also got an internal server error. I think it's just a formatting issue. So gift, single quote, by 2, and then comment. And yeah, we're still getting oh, I said group by, it's order by, my mistake. So it should be an order by. I made a mistake in this one. And this is ordering by 2. So let's say ordering by 3 and see the difference. Let me see, was there a difference in the answers? Yeah, these column changes. So you can order by 4 and see what happens, and you get an internal server error, and this is an indication that the database or the table has only 3 columns. And for now, let's use the union clause. So let's delete all of that, and let's say union select, and then we want to start with 1 column because we don't know how many columns, but we originally did now with the order by. But let's say with the union, you get an error, and then you can add another null which will indicate another column. You still get a null or server error. We can add our third null, and as you can see here, the application returned the data. And we solved the lab. As you can see, now we know that the application has 3 columns, and we can start with testing each null which data type it is, and that will be the work of the next lab. So let's continue. So database specific syntax. On Oracle, every select query must use the from keyword and specify a valid table. There is a built-in table in Oracle called dual, which can be used for this purpose. So the injected queries on Oracle would look like union select null from dual. So in previous we were using MySQL database, and for that one you didn't have to specify any table, unlike Oracle. So even if you have a SQL vulnerability and it's using a database that you never interacted with before, you might not be able to find and exploit this vulnerability just because of the syntax limitation. So for here you can find a more syntax. This is a great cheat sheet when it comes to SQL. And once we navigate into it, you can see here we have four databases. We have Oracle, Microsoft, PostgreSQL, and MySQL. Each has its own type of string concatenation, substring, comments. On MySQL you can add this as a comment, which we never used before. On PostgreSQL you can add this as a comment, which we never used before also. So it really depends on the database that you're using. You can come to this cheat sheet whenever you want, just to see commands and play with it. So for now, let's continue. And now, how do we find data types when it comes to what we did before? Finding columns with a useful data type. SQL injection union attack enables you to retrieve the results from the injected query. The interesting data that you want to retrieve is normally the string form. This means that you need to find 1 or more columns in the original query result whose data type is or compatible with the string data. After you determine the number of required columns, you probe each column to test whether it can hold the string data or not. So usually you want to retrieve data that's a string, like the usernames, the passwords, etc. So when you determine the number of columns, then you start by testing 1 by 1. You change the null into a string, you add a single quote, and then you add a character, and you see if the application didn't return any error messages, then this is correct format and this column can hold strings. You can submit a series of union select payloads and replace each one by string value at a turn to know which data type is that. And you can change it with a number, integer, etc. just to know the data type of it. And here's an example of what he did. If the column data type is not compatible with the string data, the injected query will cause a database error such as conversion failed when converting the varchar value a to data type integer or int. So it means that this column has the data type of integer and you can't just put any string into it. If an error does not occur and the application's response contains some additional content including the injected string value, then the relevant column is suitable for retrieving string data. Remember previously when we were taking with the third lab, we said that the database sometimes might add another value or another row with null values, and because now you injected something instead of the null value, this might be reflected back on the page that you have. Continue. And now we have our fourth lab or second for this video, SQL injection union attack, finding a column containing a text. So this lab contains SQL injection vulnerability in the product category filter. The results from the query are returned in the application's response. So you can use a union attack to retrieve data from other tables. To construct such an attack, you first need to determine the number of columns returned by the query. If it's the same lab, then it means that it's 3 columns by default, or they might have changed it. You can do this using a technique you learned in previous lab. We have group by or order by, and we have the union attack. The next step is to identify column that is compatible with the string data. This lab will provide a random value that you need to make appear within the query results. To solve the lab, perform an SQL injection union attack that returns an additional row containing the value provided. This technique helps you to determine which columns are compatible with the string data. So what we need to do is that similar to what we did before, we need to return the number of columns, and then additional they will provide us with a random value that we need to inject it within the page response. And now the website opened. As you can see before, it looks similar to the previous one. You can click on bits and let's see how many columns do they have. Union, select, my bad, select, and then you have null. I'll start with 2 because I don't think it will have 1 column only, and now it doesn't have 2, so probably more. We can start with 3. As you can see, it has 3 columns. I didn't get any error, and this is my null additional row that I have. So now they want me to inject this string C39 and the continuation of it. Before that, I need to know where to inject it. It can be injectable in any of these depending on the data type. Let's start with the first null and let's hit an A just to see if it can hold strings. We got an internal server error, so most probably it doesn't have string data type. Let's try the second one, and we don't get an error, and as you can see it has an A data type, so this is injectable and we can just solve the lab. But let's test the third one. I'll have it as B. We got an error, so most probably it doesn't have, so this is our only chance. We need to inject it here, C39. I will just write it PU0, and as you can see here, once I add it, it got injectable to the table or added, and we solved the lab. And that's it for this day. Hope that it was useful, and see you in the next one.